Yeah. What is this after Thanksgiving?
I have this due on Monday.
What's this due tomorrow?
Like Monday, like the beginning of Thanksgiving break?
Monday, the beginning of this week.
What about Monday after Thanksgiving?
Yes, Monday of the beginning of this week, as in yesterday. It's already late. Why are you so bad, Michael?
Why did you? I just when you already did it, turned it in.
Did you?
Did I turn it in? Did I even do it?
I signed this yesterday. Like,
I don't know
what are you talking about?
You posted it yesterday.
Okay.
Maybe.
Yeah, you probably finished.
So,
I do math in my sleep sometimes.
I wanted to go through a couple of these to kind of talk about how they work.
How many
And then I want to like prioritize. I was like 50. Like 15 pages of problems.
Double it or nothing.
Okay, so we should make it the
But I could go ahead and sit down at Unit 4's homework.
Yes.
I already have it ready.
Make it do by the end.
Because I like to split them apart, so I usually make them at the same time. Yeah, there's 50
I'm
problems.
not gonna be, I'm gonna be in the car for all weekend, for all weekend.
Let's use the double.
You know, I'll bet if you talk to me, there's a chance I might give you an extended deadline as long as I get it in.
Can I turn it in Wednesday?
I'll think about it.
I can do it.
Do I turn it in tomorrow?
Not tomorrow Wednesday, but next week Wednesday.
Oh, so I was hoping for tomorrow, Wednesday.
Yeah, like, come on.
Alright,
Fine.
number one.
Everybody has to finish this over.
If h of x is equal to 2 f of x g of x, what is the equation of the tangent line when x equals negative 1? Okay, there's no equations here. There's no functions here. You have to understand the concept of a derivative and what a tangent line is in order to do this problem. So let's talk about what we have so far. You have h of x equal to some equation, 2 f of x g of x. And it talks about finding the equation of a tangent line. Before I bother with talking about the equation that we have up here, let's talk about what the solution is going to look like. What do I need to do if I want to find the equation of a tangent line? You need to take a derivative. Why am I taking a derivative? Like, why would we take a derivative if I'm supposed to make a tangent line? What's the end goal? I want to find the slope. So I take the derivative specifically so I can find the slope. And then what do I do with the slope?
You put that in the function y minus y1 equals, was it mx minus x1? Like in parentheses, x plus x1.
Yes.
Like, ooh, don't show that otherwise. It's just 0.7. Put it in there.
I've been meaning to do this for a long time. Every time I get annoyed because I remember having to clean this thing 1,000 times. So we count. Maybe 1.5. So I take the derivative specifically to find the slope. In this case, I have this function, h of x is equal to 2 f of x g of x. So I make it my priority, step 1, let's find the derivative. If I can find the derivative, I can work on finding the slope. So how am I going to take the derivative of 2 fx gx?
Me too. That's prime is.
Incorrect.
So you're gonna use a prime.
I am going to use a product. In fact, I have to use a product. Why?
So being multiplied.
They're being multiplied. I got to use a product rule. So what's going to happen to that 2?
Just on the outside.
It's going to stay on the outside. So we have 2 on the outside. Now I use the product rule of f times g.
F prime of x times g of x plus f of x times g of x.
Okay? Now this would be h prime. This is the slope generating function of h. Now where are we trying to find the function's value at? -1. So I now want to find what is h prime of -1. But really what that means is I need to plug -1 into this equation. So remember there used to be an x, f prime -1 times g of -1 plus f -1 g prime, negative 1. Everywhere there used to be an x, I replace it with negative 1. And the nice thing is, this table contains all of those pieces. So let's pull them out. So f prime of negative 1, you said was negative 2, times g negative 1, is 1, plus f negative 1, which is 3, times g of negative 1, sorry, g prime of negative 1, 1. So I have negative 2 times 1, plus 3 times 1. Negative 2 times 1 would be negative 2. 3 times 1 would be 3. Negative 1, 2 plus 3 would be negative 1. So I have 2 times 1. So my slope in this case is 2. But in order to use this equation, I need the slope. I need one more piece.
X plus 1.
So I have x plus 1 over here. Where do you get that plus 1 from, Rico?
It's supposed to be x minus 1, but your x is negative 1, so it makes it equal to that.
So supposed to have x minus x1, but in this case my x is a negative 1, so it's going to x plus 1. That's good so far.
Plug in negative 1 to the original function.
Plug in negative 1 to the original function, so this would be f of negative 1. Goes over here for my y1 value. What is f of negative 1? 3. This would be y minus 3 equals 2x plus 1. Because you don't have the equation to be your fallback, you have to understand the rules. And the rules are specific and know what you're supposed to do with them. This is the correct solution. My equation of the tangent line for this particular function will be y minus 2 equals 2 parentheses x plus 1.
Would you plug it into h of negative 1?
Ooh, good call. You're correct. I should not do f of negative 1. That's what we normally do. But the function is h in question, right?
Yeah.
So I'm going to plug negative 1 into my h function. So h of negative 1 equals 2 f of negative 1 g of negative 1. So f of negative 1 we already said was 3, so this would be 2 times 3 g of negative 1.
So it's just 6.
So it should have been 6. Good catch. Well done. I would have missed that one. You have to be really good with your rules, otherwise you will make mistakes. 2. J of x is equal to g of x times sine of x. What is the value of j prime of 0? Ooh. Ah. Ooh. J prime 0.
Take it over.
It says j prime, so I better take a derivative of j. Now j is equal to g of x times sine of x. So if I take a derivative, what's the derivative going to look like? J prime of x.
G of x times cosine x plus g prime x times sine x.
I think about this one is like 2 just one.
Yeah, it is. Okay. Now we want j prime of 0, so I would do j prime of 0, but that just means everywhere there used to be x, I replace it with a 0. So g of 0, cosine of 0, plus g prime of 0, sine of 0. All right, let's get some pieces answered. G of 0.
Negative 2.
Negative 2. Cosine of 0.
1.
1. Plus g prime of 0.
Negative 3.
Negative 3. Times sine of 0.
0.
Simplify. Negative 2 times 1 plus negative 3 times 0. What is j prime of 0?
Negative 2.
Negative 2 is correct. These are not, in my opinion, these are some of the easier problems you have. Because you're not taking a really nasty function trying to find the derivative. You're taking functions that are simply undefined. And so as long as you have your rules memorized, it's just an application of the rule. Question in the first two. You do number 3 as well?
Jasmine Duncan in the office, please. Jasmine Duncan.
Okay, number 3, or we want to do it? Okay. I just want to make sure we have plenty of time to work on problems that are from this section. I mean, I'm not saying.
I have to go in order.
Yeah. Okay. K of x is equal to 4x minus f of x times 2g of x minus 2. What is the slope of the normal line when x equals -2? So let's talk about our components. First thing it says is this function. Cool. It asks about the slope of the normal line. Let's remind ourselves, what does it mean to be a normal line? Perpendicular to what?
The
Tangent line. Okay. So, if we can't find the normal line directly, the best route would be to find the tangent line. How do we find the tangent line? Derivative. Okay, so we're going to find k prime. What are my ways of doing this? Could do a product rule. So you would do left d right plus right d left. How else can we do it?
And you just plugging the f x not t of x. Are we still getting, is it supposed to go to the top?
Mm-hmm.
Yeah, so we just do that. It would be easier to just use.
In this case, f and g are still unknowns. And we can't plug it in until after we've taken the derivative.
Right.
You could just FOIL this out if you really wanted to.
Ew.
So you could take 4x times 2g of x, 4x times -2, f of x times 2g of x, f of x times -2, and you could just FOIL it out and see if it makes it nicer. There's a chance it does. There's a chance it doesn't. I think it's just an option. Okay? But I'm going to go ahead and do the product rule. I think it's the best way. Use our rules correctly. So I would do left d right. So left 4x minus f of x d right. So that would be the derivative of 2g of x minus 2. The derivative of 2, well, it's a constant being multiplied, so I'm going to ignore it. The derivative of g would become g prime, so 2g prime of x. -2 is a constant, so when it's derivative, it's 1, it becomes 0. So left d right plus right d left. So this should become 2g of x minus 2 times derivative of the left function. So derivative of 4x, 4, minus f of x, f prime of x. Like I said, you could, if you really wanted to, FOIL it out, but I think this one's just fine. What next?
I'm kidding.
I mean, you could.
Yeah, I think.
That's probably what I would do. Yeah. Because what do I want? What's my long-term goal? Think, problem, long-term goal.
So normal line.
So the normal line. I can't do normal line, but I can do the tangent line. So how do I find the tangent line now that I have the derivative?
Plug in.
Yeah, you gotta plug in, right? I was gonna plug it in. Could I simplify this down? Yes. You better believe I could. Do I want to? No. You better believe I don't want to. So we're just gonna do 4 times -2 minus f of -2. So again, everywhere there used to be an x, replace it with -2. So 2g prime of -2 plus 2g of -2 minus 2. Oh man, there's a lot of 2's in here. Times 4 minus f prime of -2.
I'll pull it up so you don't have to go up on the table.
Much appreciated. So otherwise, I'm going to have to erase all this,
Yeah.
and then we're going to have to try to remember it, and that's never going to end well for me. So I can use some of this already. 4 times -2 would be, this would be -8 minus f of -2. I'll get to that in a second. This is 1,
Yeah.
so minus 1. 2 times g prime of -2. So 2 times 4 plus 2 times g of -2.
Which is 2.
Is g of -2 2, or is g of -2 1? So therefore 2 times it would be 2.
It's 2.
Okay. Minus 2. And then I have 4 minus f prime of -2.
-1.
-1. Okay, well already I can see that 2 minus 2 is going to be 0. And anything times 0 is going to be 0, so that's gone. Will that make sense? This would be negative 9 times 8.
Oh, 8. I was right.
Yeah, you were.
72.
So negative 72.
I started to add it.
This would be the equation, or the slope of the norm of the tangent line, right? How to find the equation of the normal line?
1/72.
Yes. So therefore, the normal line (1 over 72) or 1/72. Yeah.
Well, decimal would it be?
0.01713.
That's not really what it was.
I have no idea. Took a shot in the dark. And if I'm close, it sounds impressive. If I'm not close, I'm just like, it happens. I do that trying to trick class all the time. Ha
It's like 0.1.
You just say, like, you look at, like, say there and think about a number, but you really have no idea.
No clue. They're like, hey, what's pi over 5? And I'll just be like, I'll take a guess here, 0.6173. And they're like, it was 0.627. And I was like, yeah, I was that close. And they're like, you're good. I'm like, yeah, I'm totally good. I can usually get pretty close. It's a lot of mental math. Okay, 4 to 6 is very, very similar, just with slightly different functions. Can you see them? Okay. So just very similar. It's a quotient rule instead of a product rule. Alright. So again, very similar. We've got the function f of x equal to the square root of 25 minus x squared is pictured to the right. Use this function to complete exercises 7 through 9. 7. Find the values of f of 3 and f prime of 3.
What are you trying to say? Speak loudly. Other crowd. Other 3 would be.
Yeah, f of 3 would just be plugging in. But you gotta remember, my picture only shows one solution. It should be on the picture in the solution, right? In this case, f of 3 would just be 4. We are smart enough in calculus to be like, yes, there are 2 solutions, but if you look at your picture, they get by this because this function, if you wanted both solutions, it'd have a plus or minus in the front of it.
Right.
Indicating there should be 2 versions of the function. Since it doesn't have that, we assume it's only working with the positive because it's a positive square root. And what's annoying is half the time it doesn't matter, and half the time it matters a lot. And that's super
It always
irritating.
matters when you forget it.
And it never matters when you remember it. You're just like,
Yeah.
ah! And you're like, nah, bro, we're good. Alright. Next step, f prime of x is the first thing we need to find. We have the square root of 25 minus x squared.
Put 25 to the 1 half.
So 25 minus x squared to the 1/2 power. That's a good first step. Oh, I can't hear you very well, I'm sorry. Go ahead. Nope. No! That is not how that square root works.
But you put the 5 squared, and then you put the half, and you try to
No, you
put it
can't.
all through.
No.
When you factor, you get x plus 5, x minus 5, which is not a perfect square, therefore you cannot cancel.
But that's a negative x. So wouldn't it be negative x plus 5? No.
Which said 25 to
Just
5
calculate that.
squared.
You'd have difference of squares, which becomes 5 minus x, 5 plus x,
Oh.
which is still not a perfect square.
Chain.
Chain rule, gotta do it.
I was
Okay.
trying to do that. I was trying to do it on my head. but-
Chain rule. What does chain rule say to do?
1/2 25 minus x squared to the negative 1/2 times 5. Wait. Oh, negative 2x. There we go.
Okay, you might be asking yourself, hey, I should probably simplify this.
Ah, man.
Nah, bro.
No.
I want to find f prime of 3, so I'm just going to take f prime of 3 and plug it in. 1/2. 25 minus x squared, so it's x squared. I have 3 squared. Negative 1/2 times negative 2 times 3. Alright, one piece at a time here. 1/2 times 25 minus 3 squared. 3 squared is 9. 25 minus 9 would be 16.
16.
1/4, so 1/8, so 6, 8, 6.
So negative 1/2 power, this would become a 1/4 power, or 1/4. So you have 1/2 in the front and 1/4 from the negative square root. Okay, negative 2 times 3 would be negative 6. That's multiplied. 1/2 times 1/4 times negative 6. I can cancel 2 from the 6 with the 2 out front. Negative 3/4.
Yes.
Does that make sense with our picture? Here is the point 3, 4. Here's the tangent line. I think that makes pretty good sense. It is a negative value because going down. It looks like it's less than 1. I think it's pretty decent. Remember, slope of negative 1 would be from here to there. And so it's pretty close, but definitely a little less. Yeah, negative 3/4. All right, now, this is famous AP style questioning because number 8 is much easier if you do this correctly. Number 8 says, find the equation of the line tanges the graph fx when x equals 3 and graph this line on the grid. It says, find the equation of the line tanges the graph fx. How do you find the equation of a tangent line? Derivative.
Yes.
But we already found it. And we already found it for this specific point. Do not redo your work. F of 3 is 4. F prime of 3 was negative 3/4. So let's make our equation. The normal equation is y minus y1 equals m parentheses x minus x1. So I put in y minus what? Y minus 4, yes. Equals
Wait, is it tangent? Oh, never mind. Yeah,
tangent.
tangent. I don't know what's the normal one.
I know.
Yeah, -3/4.
Negative 3/4. X minus 3. Beautiful. Yeah, don't double up your work. That's why there's a smaller space there. It should be a hint that you don't expect to do a lot of work this one. And graph this line. So I would do is the bare minimum. In geometry, you know that 2 points make a line. I would find a second point, graph that point, and then connect dots. You don't have to go any faster than that this one. So I'd plug in, instead of 3, I'd plug in like either 2, 1, or 0. I'd plug in 0, I think it might be a little easier. But I would probably want to find one that makes this a nice number if I physically can. I think negative 1 is the next number that makes it really nice. Or positive 5. Positive 7. See?
If you really wanted to do it, you could just do it. Use this one.
So then you'd have y minus 4 equals negative 3/4 x plus 9/4. You want to move the 4 over. If I add 4 to both sides, this will become y equals negative 3/4. So what I would probably do is, if I'm honest with you, I would do rise over run with negative 3/4. So up 3/4. Done. There are so many options for how you can approach these kinds of problems from algebra. Like, just find a way, please. Okay? Find some path that gets you there. All right. If you did bother to convert it, then this last piece is actually a little bit easier, but not much. Number 9 says find the equation of the normal line. It's just a reciprocal of the slope itself. So everything else about it's going to stay the same. So it'll still be y minus 4 But instead of negative 3 over 4, it'd be positive 4 over 3. X minus 3. And this one's pretty easy to distribute and get your results, but if not, normal line is not too bad still. So we put it on the picture. The normal line would have a dot right. I pressed the wrong button. I'm silly. The normal line would have a dot right on the same spot. So right there. And then it should cross over here at positive. Instead of up 3 over 4, it'd be down 4 over 3. Positive.
You're so quiet.
Except outside, apparently. I don't know what goes on outside of my room every block. I think they have a party notified me.
Maybe if you walk out there.
Oh, heck no, I like it here better. Alright.
There's a little party when you're just chilling right now.
For this one. At what values of x is the graph h of x equals 1/2 x squared square root of 2x plus 1 have a horizontal tangent? This one? It's a definition problem. If you understand what the question is asking when it says horizontal tangent, then the question is actually a pretty straightforward question. If you don't, then this question is a lot more difficult. Say again? Y-intercept has nothing to do with it being tangent.
Oh, no.
So, if you have no idea, then that's your choice, right? Not just for your homework, but I would suggest this would be one thing to add in the notes if you don't remember. What does a horizontal tangent mean? What if I ask a different question? What does horizontal mean in terms of the equation?
Slope 0.
Slope of 0. So what this question is saying is, we want to have a slope of 0 tangent. So what this is saying is, when will the derivative equal 0? Find the derivative. This is a question asking you to find the critical values. Because life is more fun and interesting when you have to give it this way.
Or it's more fun and interesting when you hold up in a fetal position.
Yep. Pretty much.
Yes.
Because what you have to understand is that, how can I put this correctly? I like that you put it there. Thank you. Real world problems aren't as nice as telling you how to solve them. I've never seen a realistic mathematical problem. Like, we had to do some data analysis when it came to like stock pricings when I worked for Discover over the summer. This was during my sophomore year of college. And they were asking questions that were like, okay, we want to find where's the minimal risk. And like, you have to sit there and be like, okay, you have to take what the customer wants, you have to interpret that into some kind of mathematical statement you can find. Well, minimal risk just means find a minimum. Finding a minimum means critical values. Critical values means derivative. So if I have a function that I can work with, then I just have to take the derivative, find the critical value, determine which was the minimum, and I'm done. But the customer doesn't know to tell me that. The customer has no clue. They're stupid. They didn't take Calc. They have no idea. That's why they pay me, right? Same for you guys. Like, you have to think this person is telling you what they want. It's your job to go back and go, okay, you're telling me this. What does that really mean I need to do? What's my actual work going to look like? And for this problem, it just means find when the critical values are. There's so many ways of phrasing this that, like, depending on the situation, you may have it one way or the other. One of your homework problems from last week talked about finding the maximum area of a beehive, I do believe it was, which is really cool, right? But maximum just means critical value. Critical value just means find a derivative instead equals 0. So yeah, it has a cool little statement in terms of a realistic problem, but what that actually interprets to is the need to take a derivative. And it's up to us. That's why we have this class. That's why we would take this class, so that hopefully somebody has a problem, they can come to us and go, hey, how do we do it? We go, Okay, you have one thing you want, but what I mean is, let's do this instead. Take a derivative instead equals 0 and solve. Let's sort of get to some that are more like what we have here. There we go. If h of x is equal to the square root of f of x times g of x, what is the graph of h of x increasing or decreasing when x equals -1? Give a reason for your solution. Okay. Interpretation. What is this function actually asking me to do? And how will I know what the answer looks like?
We want to find your critical values first to figure out which ones are your maximums and which ones are your minimums.
That'd be great work. Not actually required for this problem, as weird as that sounds. Normally, if we wanted to find the intervals of increasing and decreasing, you would be exactly right. You're actually doing far too much work. Because this isn't asking for intervals of increasing and decreasing, it's asking, is it increasing or decreasing specifically here?
So just take a derivative and plug in that.
And what are we going to learn?
If it's positive, it's increasing, it's negative.
Perfect.
Yeah.
Fantastic. So let's, increasing and decreasing, we did a lot of practice problems where we talked about the intervals because that's the primary use of them, but if they mention the word increasing or decreasing, it's the same concept. It's focusing on the derivative. But increasing just means the slope is positive. So it's asking, this question is asking, hey, is the slope positive when x equals -1? Or is the slope negative when x equals -1? Again, they're not coming out and saying it. That's what we are here to earn the big bucks for. Okay, we want to figure this information out. So let's try it out. If h of x is equal to that equation, is the function, so graph h of x increasing or decreasing when x equals -1? Give a reason for your solution. Step 1, if I want to determine increasing or decreasing, what's the first thing I'm going to do? Take the derivative. You are right, Abby. We're going to take the derivative. Let's take the derivative, Abby. I thought you were Abby, but that's okay.
Oh my god, come on.
Dad jokes.
Chain rule or product within a chain.
Product within a chain. Oh, baby. Okay. So I'm going to take my step 1 to be to rewrite this, make it a little easier to do. I have f of x times g of x. The square root becomes a 1/2 power. Step 1.
1/2
1/2. What happens to the inside?
stays the same.
Stays the same.
1/2 power.
1/2 power.
And then
Times.
times the derivative on the inside.
So I'm going to open a bracket because I want to take the derivative of the inside. This derivative is not as nice.
F of x times g prime of x
f of x times g prime of x.
plus g of x times f prime of x.
G of x times f prime of x.
And I think that's equal to that.
Beautiful. Because I'm not going to simplify that. There ain't anything to simplify. So let's pull out that table. We want to find when x equals -1. So what this is saying is I want to find h prime of -1. And my goal is at the end, I'm going to get a number value. I want to interpret. Is this mean it's increasing or does this mean it's increasing? Is it positive or is it negative? So I have 1/2 f of -1 times g of -1.
1.
You said 3, 1, so 1/2 of 3 times 1 is -1/2 power times f of -1,
Which is 3.
3 times g prime,
1.
-1, so g prime, -1 is 1, plus
1.
g of -1, which is 1,
And then -2.
f prime of -1, which she says is times -2. Times. Alright, so far we can here. Alright, we'll go over here. This is equal to 1/2 times 3 times 1 is 3.
I really have like
Parsing interruption, but teachers, I need all freshmen to report to their seminar class at this time.
Never.
All freshmen report to their seminar class.
Yeah, so they're gonna be
It's
quarantined.
great that you have these here for their
At this time, thank you.
IDs.
IDs.
I did,
Make sense?
It's great
I like
that
how they told us.
It's great that you
Okay.
understand the class.
I'm going to go ahead and take a second and point out something very, very, very important. I do not care what the answer is. Do I?
We just care if it's positive or negative.
Because I care if it's increasing or decreasing. Good catch. Okay? So, I'm going to ask a question.
Just to clarify, this is freshmen only.
Positive. Positive. Because this negative power is going to mean it goes to the bottom of a fraction. It's going to be square rooted, but I'm square rooting a number in calculus. We don't get imaginary, so it's positive. So positive times positive. All you need to figure out is if this is positive or is it negative. This is also positive. 3 times 1 is 3, plus 3, 1 times negative 2 is negative 2. So this is increasing. Now, it says give a reason. That's slope is positive. So I might say slope is bigger than 0. Therefore, it's increasing. That's how we say it mathematically. Since the slope is greater than 0, it must be increasing. Other way to say this, we got there by the first derivative test in a weird roundabout way. We didn't find the critical values to get there, but we did test the first derivative to determine increasing and decreasing. So you could also reference that as well. But as long as you include something about the slope being bigger than 0 or the first derivative test leading to increasing, both are fine. This one's just the same concept as before with the chain rule. Okay, a lot of practice for that kind of stuff. A lot of these first problems I wanted to be weird, like AP style.
I think I didn't like these problems. Then what we have to do.
They're different. I prefer the ones with a formula, I'll be honest. Because, well, I'm a math person. I'm used to a formula. Give me a formula so I can work with it. I get really annoyed when I don't have a formula.
Just make your own formula.
I know, right?
When I saw this game, I was like, okay, we gotta make a formula. Wait.
I mean, I like the tables, but I like the increases and decreases.
Same. Okay, let's talk about this since we have last question. Graphically, identify a value of x in which the function is continuous but not differentiable. Give a reason for your answer. Let's remind ourselves of those definitions. Continuous means that there are no asymptotes, no holes, no jumps. So if you look at this picture, it looks like everywhere is continuous. So every x value appears to be continuous. However, to not be differentiable. And don't forget, the term differentiable means a place where I could take a derivative. So where could I not take a derivative?
Right there.
Probably.
Yeah.
You can't go past
2 1.
20.
Why 2-1?
Because it's undefined.
So ask for a value of x is being when x equals 2. But when x is 2, it is defined. Because when x is 2, the function has a value of 1. So why is it not differentiable?
Not a straight line.
Well, neither is the right-hand side. Straight line is not a requirement to be differentiable. To be differentiable, it means there has to have a derivative. To have a derivative, it must have a definable slope. Look at 2. Cannot have a definable slope. The reason why is the limit. The slope on the left-hand side is clearly negative. The slope on the right-hand side is clearly positive, but this is not a 0. There has to be a place where it levels off. This is piecewise. So the fact that this point right here does not level off, it's a hard corner, means it's not differentiable. The limit from the left-hand side is a defined value, a number that is negative. It's not getting close to 0. It is a number. That number is what, negative 1/2? On the left-hand side, this is the slope. It's negative 1/2. On the right-hand side, this slope looks really close, like positive 10 or something. It's pretty big. My left side and my right-hand side are not agreeing upon a value, therefore it's not differentiable. 14 is fun. Writing an equation. It's a fun time. We'll put a stop there. The bell's about to ring. You shall live.
Everyone